All right, so recording for part 2. You guys are just coming back from doing this launcher lab. You guys took the launcher and you did something with it. Now, remember, there were 2 questions going around, and you guys did, found some data, you guys crunched the data, and then you answered one of 2 different questions. You answered either what was the firing speed of the ball launcher, or what was the optimal firing angle to launch the furthest horizontal displacement. Before you guys went out there, showed you guys some setups and some possible tables for that. Now, some of you guys did point out that actually a good column for the table would have been time, either by directly measuring with a stopwatch or by calculating it based on the drop height. If you did something like the setup, yeah, that would actually be a good problem to have. That aside, now I did my best to get some of those pretty close to an AP rubric. This is not perfect, but it adds up to 12 points. So, all right, let's start with firing speed. You had to have had a meter stick. Do you guys do meter stick? Give yourself a point for that. Right. Also, well, I wanted to come up with some other point. Could have used some other tools possibly. If you mentioned using a scale to measure the mass of the ball, which kept constant throughout the experiment, give yourself a point for that. You might have used a protractor or a stopwatch, depending on how you went your setup and how you gathered the data. Right. If you answer this other question, what was the optimal angle to send at the furthest horizontal displacement? You would have had to also have had a meter stick, so you can measure how far. Right, and definitely you would have needed a protractor. Okay, you might have used a scale to measure the mass of the ball. That would be good practice to know that the ball was 10 grams or 0.01 kilograms. Okay. You might have used a stopwatch, but not really necessary. Okay. Right. Data gathering procedure. Right. So this is all about just gathering the raw data, basically how to fill out the table. And maybe you had a better table than I did, because maybe you even had the middle step of the time. Right. One way or the other. You should have. Okay, so this is for firing speed. To get the firing speed. Set up a ball launcher at the top edge of a cliff, right, or on the ground, depending on your setup, and aim it straight horizontally from the top of the cliff, or straight up from the ground, right? Or you could even do it at an angle from the ground. So as long as you had a brief description of the experimental setup, give yourself a point. Use the scale to measure the mass of the ball. Keep that mass controlled during the experiment. If you reference the mass of the ball, because you can imagine, well, if you change that out, that'd probably change the firing speed. So that's just one of those details that would be good to mention. That's worth a point. Measure the height of the cliff with the meter stick. Give yourself a point. Or if you did a different setup, if you measured the launch angle, say you were down on the ground level, protractor, give yourself a point. Right. Launch the ball and spot where it lands. So give yourself a point for that. Right. Or if you aimed it straight up, then it's maximum height. Right. Measure the displacement with the meter stick and record that. So, right, point for that. Right. If you included a step that said do multiple trials, it's like repeat the last step several times and find an average. Right. You guys know that AP is going to ask about this so that you can help reduce your random error. Right. You guys know it's going to be a point on the AP exam in May, right? For the experimental design FFQ. All right, now that's all pertaining to ultimately finding the firing speed. Right? That's just gathering the data. Notice I haven't included any equations yet, because that's the next step, or the next section. Right? But before I move on to that, let's see what some good steps would have been for optimal firing angle. Let's say you were wanting to get that. So brief description of experimental setups worth a point. Measuring the mass of the ball as a point. Using the protractor to measure the initial angle, that's worth a point. Launch the ball and see where it lands. Measure that horizontal displacement with the meter stick. 1 point using the meter stick. Repeat several times. 1 point for multiple trials. Determine the average horizontal displacement. Identifying the dependent variable. Okay. Now these do not line up exactly left and right, but I'm just trying to make each side add up to 12. So, right. And then finally, increasing the firing angle by so many number of degrees, basically using the angle as an independent variable, and explicitly mentioning that you're using lots of different angles. Right, so 1 point for identifying the independent variable. All right, next section. The next section is how to analyze the data. Now, in your last lab with the car and ramp, I had you guys use graphs. So you graph x versus t and then x versus t squared. We do all kinds of graph manipulation, that sort of thing. Right. Now this lab, you want equations. You want, okay. You guys remember these formulas right here? Right here. Let me run through exactly what most of you guys did. Right. Most of you guys did this setup, and if you did this setup, then you would have needed. Okay, so the blast speed would have been how far divided by how much time, so x over time. Right. But what was time? Well, you could have gotten it directly with the stopwatch, or probably a better idea to do is to calculate based on this drop height. Now, this drop height, how many meters did you guys get for the drop height?
4.05.
Huh, interesting. Okay, right. So whatever that number that was, right? Plug that in there. You guys got about 9.8 or 10 meters per second squared for G. Could you guys back calculate the T? Right? Probably come out to close to a second for most of you guys. Right? And then once you have that time, pop it in there. Right? So that's reference to that. Right. Or if you aimed it straight up. I know some of you guys aimed it straight up. If you aimed it straight up, you want to use this bottom equation. What you want to do is say, goes from some blast speed to 0, and then gravity's pulling it about 9.8 or 10 meters per second squared, goes to some maximum height, and then you can solve for the blast speed based on that. Right. All right, so how are the points going? Right, so here I've got different sections depending on your setup. So if you launch it horizontally from the top of the cliff, that's the setup here. I think most of you guys did that. If you rearrange the formula h equals 1/2 gt squared to find an expression for time, you got time as the square root 2h on g, or just if you plug in the numbers and found time using that method, give yourself a point for that. Actually do 2 points because I was trying to make them add up to 12. So 2 points, correct kinematic equation. Thanks.
Mr. Griffin?
Yep.
Those two only if we did it, like, or if we actually wrote down the procedure for it.
Okay, so what you're looking for is under the section how to analyze data, you want to write the equation h equals 1/2 gt squared and then solve for t.
Okay.
Right. If you did that, give yourself a couple of points.
I did it on the other side, so that.
Okay, yes. If you have it, yeah, just go right into there. Okay. Okay. And then to determine blast speed, divide the horizontal displacement by that free fall time that you calculated using the first bullet. Right. That's another couple points. Trying to get up to 12. Okay, so if you did all that stuff, let's just call it 4 points. Okay. Sometimes AP finds a way to divide those smaller steps and something like that. Now, if you launch the ball at some angle, which would have been this process, which is probably the hardest way to do it, then you could, well, here, I'll just flash this up here. You could solve it using kinematic equations. It's just a lot harder to do. It's a much longer process, but same equations we've been using all class. Right? Did anybody do that? Did anybody aim it at an angle? No, I didn't think so. Right, so moving on. If you aim it straight upward, and I know some of you guys did this. If you aim it straight up, then use vf squared equals v naught squared plus 2ax. X is the maximum height. A is the gravity pull, 10 meters per second squared. One of the v's is 0 because the max height is 0. The other one represents your blast speed. So 2 points for the correct kinematic equation, and then substituting the average blast height into the equation to determine speed. So 2 points for rearranging the equation and solving for blast speed. Right? If you tackled the other question, what is the optimal angle for the maximum horizontal displacement? Then probably the best way to do this would have been to make a graph, right? So I would find a darker color. Right. So if you did the experiment that was you were blasting at some angle and you were changing the angle and trying to figure out how to maximize this horizontal displacement, what I would have done is this. Said, I'm choosing lots of different angles, maybe in degrees, right? Mark those out. So 0 up to, you could have gone up to 90, right? And then say, how far did it go in meters? Up to, however far it went. Okay? And you probably got some data that looks something kind of like this, right? Where if it's a small angle or a large angle, horizontal or vertical, it probably didn't go too far. But it's somewhere in the middle would have maxed out. And what you can do from that is draw a curve of best fit. And then this maximum height, call it X max, or sorry, not height, horizontal displacement. Right? That maximum horizontal displacement would correspond to some optimal angle. We'll call it theta optimal. So good way to do that experimentally. So 1 point for plotting x versus theta, 1 point for determining theta from that. Draw a curve of best fit, determine the optimal angle by finding the maximum point horizontal displacement. So basically, what I just said is for a couple points. Okay, guys, good so far? All right, finally, bringing this for conclusion. The answer to your question. I mean, you guys asked a question in the beginning, so I hope you guys have an answer at the end. So either the blast speed is so many meters per second, so 1 point for getting a number of meters per second. These numbers have units attached to them, right? It's a speed, right? And if you went the other way, if you solve for the optimal angle, then you would say the optimal angle to send the furthest horizontal displacement is so many degrees. And you want to specify either to the horizontal or to the vertical. Otherwise, it's like, well, degrees relative to what? So I said to the horizontal. So 1 point for a conclusion that matches the question. Okay. All right. You guys got that? All right, so should add up to 12. So take your colored pencil and score yourself